Well, thank you so much, everybody who is able to join today. If you haven't already done so, please go ahead and grab a piece of paper and a pencil. We will be working through a few example problems and would love for you to have an opportunity to follow along as we go. And without further ado, I am going to go ahead and kick it off. So from here, what we're going to do is do a quick workshop to review some of the different interview functions that we have here at Capital One for the Technology Development Program. So first and foremost, Sarah is going to go ahead and start us off with the job fit section.
Hi, so my name's Sarah. I've been at Capital One for almost 2 years now. And I work in card tech as a software engineer. I graduated from Virginia Tech in 2017, and as a fun fact, I have over 60 first cousins, so pretty big family. All right, so the interview process at Capital One has 3 different interviews. Today we're going to be talking about the technical job fit, as well as the case interview, because I think the behavioral interview is very similar to behavioral interviews that you might see in other job interviews, and the case and technical job fit are a little bit more specific to Capital One. And I give job fit interviews, so I'm going to be talking about the job fit interview portion. So some common topics that you'll have in your job fit interview is we'll ask about technologies you're familiar with. We'll ask you to maybe demonstrate some high-level algorithm or system design, or possibly to implement a specific algorithm or solve a problem. So those are things that you should be familiar with coming into your job fit interview. And some of the things that we want to see your problem-solving, analytical, and design skills. To that point, it's really important that you make sure while you are coding that your interviewer is aware of what you're doing so that we can kind of understand your problem solving in your design process, not just the solution that you run into or that you come up with. We also want to see that you have the ability to recognize and fix your mistakes so that you have those debugging skills. We'd love to see correct and efficient solutions. But obviously, if you can't come up with the most correct or most efficient, being able to identify where those weaknesses are and how you could make your solution more efficient is another important thing that you can think about. And of course, we always want to see people who are excited about joining the company and have those character traits that we think would be really successful at Capital One. And then on the opposite side of the spectrum, the things we don't want to see, we're not so concerned with like perfect execution. You don't have to have the most ideal code as long as you're able to fix your mistakes and you're able to point out like areas of improvement. We also don't want to see like heads down coding. So as I mentioned before, that communication between you and your interviewer is really important so that your interviewer knows what you're doing and that they can kind of understand your thought process. And then we don't want to see any sort of like arrogance or I guess don't feel that you can only solve a problem in one way or oversimplify. Be open to I guess, different ways of solving a problem and be open to any changes if your interviewer like asks you to think about coding it in a different way. All right, so going into the interview, you should really have a good understanding of object-oriented concepts. So classes, inheritance, polymorphism, and proper OOD. You should know your data structures and your common algorithms for each data structure. So you don't have to like know how to write these data structures from scratch, but you should be able to use them or execute them and talk about kind of how you would optimize a solution using a particular data structure. It's also really important that you know the language-specific data structure libraries because we don't fault you for like syntax when you're doing the job fit interview. But one thing that we definitely note is if you are trying to have your data structure do something that it physically cannot, dependent on the language that you're using or the data structure that you're using. Yeah, and then apart from that, we'd also recommend that you go over common design patterns, and then you reorient yourself with big O complexity for speed and memory use for like your particular data structures, or I guess, yeah, practice problems. Okay, so when you get to your interview, the job fit portion will have a number of coding questions. And before you dive in and start solving, it's really important that you understand the problem. Your interviewer is there to help get you to the solution. And we really encourage that you ask questions and that you state your assumptions and you walk through some simple examples, whether they're given to you by the problem or you come up with simple examples on your own, just to make sure you absolutely understand the problem before you start solving, so that you don't like waste your time accidentally solving something that you weren't asked to solve. And yeah, as interviewers, we're here to help guide you in the right direction. And so we definitely encourage as many questions. There's no dumb questions. Like, feel free to ask as many and as often as you think would help. And then after you think you understand the problem, I would recommend making a plan. So you could think about like different approaches to the problem. If it's like optimized in one way, but you're giving up like space complexity in terms of like, or instead of time complexity. Discuss problem points and look for keywords. And then after you've made that plan, make sure that you're choosing a solution that you feel comfortable implementing. Like, for example, if you recurse solution to this, but I'm not very comfortable or familiar with recursion, I would recommend instead going with something that you feel comfortable with, that you think you can complete the problem successfully with. So while you're solving, again, communication is really key. So if you're the kind of person who can talk about what you're doing while you're doing that, that's wonderful. If you're not, just make sure you're pausing every so often to kind of talk through like what you've written, just to make sure that you and the interviewer are still on the same page. And then you want to design your algorithm or your solution. And it's important to identify areas of inefficiency, consider size of data sets. And then again, like I mentioned before, if you could use recursion or dynamic programming and you think that it's a better solution than perhaps an iterative or looping solution, that's something you're more than welcome to do if you're comfortable with it. And then breaking down the problem is also really helpful when going through and designing your algorithm. And then it says here as a bonus, test-driven development. While that would be like really impressive for us to see test-driven development, I would say given time restraints, it's not something that I, as a job fit interviewer, have seen someone do before. And while it would be really impressive for you to walk in and write out your test suite before you start writing the algorithm, in the interest of time, I would recommend probably steering clear of test-driven development unless you're very confident that you can get it all done in time. And so then after you have your solution, make sure you're actually stepping through your code and you're evaluating it. You're not just taking whatever sample test data you're using and assuming that your code is running correctly. Make sure you're actually looking through the syntax. Back over your work, test it. If the problem provides like a data set, you can use that. If it doesn't, go ahead and come up with your own. Definitely think about those edge cases, and you can think about creating data sets to help verify that you're reaching all those edge cases. And again, yes, step through your code. That's really helpful. And then, yeah, I already covered, make sure you're using a good sample data set, whether it's provided for you or you come up with one on your own and you're thinking about those edge cases. All right, so now we're going to give you a sample question, and I'd like everyone to just take a minute and think about how you would go about solving this. So using some of the strategies we identified earlier. So the question is, given two strings, write a method to decide if one is a permutation of the other. And we'll go through a couple possible ways of solving this in a second. Okay. So now that you've gotten like a minute or two to think about this, the first thing that we would want to do before we get into designing this solution, we'd want to ask questions. So is the permutation case sensitive? What kind of characters are supported? Only letters? What about symbols or spaces or numbers? Should there be a limit on string size? If spaces aren't included, should they be removed, or should the only first word be used? So these are all questions that are really important to understanding the whole of the question, and these weren't necessarily answered by the question itself, and they can really change how you go about solving the question. So it's really important you make sure you understand all of what you need to do. Okay. So now that we've gone through and we fully understand what the question is, and the answers to those questions on the previous page might change depending on your interviewer. So while you might get the same question as someone else, you might have a different execution. It all depends on what your interviewer is specifically asking you to do. So now that we've got those questions out of the way and we understand, we're going to think about what are different possible solutions that we could implement to solve this question. So the first possible solution is we could loop through the first string for each letter, see if there's one matching in the other string. And then if there is, we could remove both letters. And then if the strings do not end at 0 length, we know there are no anagrams. So we can analyze this solution and look at the pros and cons. So the cons are that it runs in big O of n squared because it makes so many comparisons. And then removing letters from a string or character array would be fairly expensive. But the pro is that we can perform this in place, so it's fairly memory efficient. So another possible solution would be that we could sort the strings as a character array and then do a linear comparison to check for equality. So the cons of this particular solution is that it requires a transformation from a string to a character array. And then sorting is slower than linear big O of n log n. So if we could have a solution that was O of n, that would be superior. But the pro is that this solution is really simple and easy to implement. All right, now the third possible solution, we could loop through the first string and store counts for each letter, and then loop through the second string and store counts for each letter, and then we could compare the counts, possibly using a hash map. So the cons is that it uses a lot of extra space with 2 maps, but the pro is that it has a relatively fast runtime of O of n. So now that we've established 3 possible solutions, you would kind of work with your interviewer to decide which one you should implement based on what their priorities are. If they say perhaps like time complexity is more important than space complexity, or space complexity is more important than time complexity, so on and so forth. But another thing we want to identify is also problem points. So depending on how the interviewer answers the questions so that we identified earlier, dealing with spaces could add another layer of complexity to identifying whether or not there are anagrams. And then the resizing of a hash map as more letters are added, or using too big of a hash map for small strings could be another possible point of complexity. So another thing I just want to reiterate is that of all those possible solutions we came up with, I would say that any of them could be like accurate solutions as long as you're like making sure you're writing good code, you're talking with your interviewer to identify what they think is more important, and you're getting like a working solution and you're debugging. So I wouldn't get necessarily caught up in, is this the most efficient solution in one aspect, as long as you have a reason why you chose to implement that particular solution. Because again, we're really just trying to look at your thought process. There's no one concrete right answer for any of these questions. So there's another question up now. Write code to remove duplicates from an unsorted linked list. I'll give you guys another minute or two to kind of think through this and how you would go about coming up with possible solutions. Okay. So again, we want to make sure we're asking questions to fully understand the question that we're solving in the interview. So some examples for this question would be, is it singly or doubly linked? Which is important because if it's doubly, you don't have to keep a reference to the previous item. And then, is it circular? Because if it's circular, you need to know when you hit that first item again and you're going back around. So one possible solution would be that you could sort the linked list and use 2 pointers to iterate through the linked list, starting at position 0 and 1. And while the second pointer points to the same value as the first, you can remove the node at the second pointer. And if they're not equal, you can increment the first pointer and check again. So the cons here is that it requires sorting, which adds an increased complexity of at least O of n log n, depending on which sorting algorithm you use. And then pros, it's a simple algorithm that runs in linear time of O of n. Okay, a second possible solution is that you could use 2 pointers to iterate through the linked list starting at position 0 and 1, and you iterate the second pointer over the whole list, and if the 2 pointers reference the same values, you can remove the node that the second pointer points to. And then when the second pointer reaches the end of the linked list, you can increment the first pointer and reset the second to be at the next position after the pointer. So the con here is that it's relatively inefficient runtime of O of n squared, but it doesn't use any secondary storage. Okay, so a third possible solution could be that you iterate through the list, checking if the current value exists in a hash set. If it doesn't, add it. If it does, remove the node. So the con here would be that it requires a secondary storage structure, so it might not be ideal if space is more important than runtime. And then the pro is that it runs efficiently in O of n, and it's a fairly simple algorithm. So again, before you dive into like writing your solution, you want to make sure you fully understand not only the question, but also any impediments you run into. So a couple problem points. So if the interviewer says the linked list might be circular, you're going to need to account for that and keep a reference to the first node to check if your algorithm has reached the cycle and started over again at that first node. Another possible problem point, you could hit a null pointer exception when reaching the end of the list. And this is something that you should look out for in general, because I think null pointer examples are a fairly common pitfall. Not just when working with linked lists, but when working with any sort of data structure or list or array. And then out of bounds exceptions also are important to keep an eye out for. And then make sure you're properly removing the nodes from the list, because half the problem is finding the duplicates, but the other half the problem is correctly removing them. So make sure you're actually completing everything that the problem is asking you for.
Great. Thank you so much, Sarah, for going over some of the prep material for our job fit interviews. From here, we're going to transition into a little bit of the case prep, and I'm going to hand it over to Joe Patrell.
Hello, everyone. My name is Joseph Walshell, and I'm a distinguished engineer at Capital One in our shared technology division. I've been with Capital One for almost 20 years. An interesting fact about me is that I've won 5 of our internal tech excellence awards. And on the fun side, I really enjoy playing and designing all different types of strategy games. So what I'm going to do is take you through what the case interview is. So here you can see the outline of the different sections of a typical case. Not every case follows this exact same outline, but this will give you a feel for what the case is like. When the case interviewer enters the room, you'll have a moment or two to introduce yourself, check how you're doing, but then the caser is very quickly going to go into sort of setting expectations for the case. And usually this will involve asking you as a candidate if you've ever done a case interview, if you had reviewed any of the prep materials or attended this workshop, for example. And then we'll sort of give you the base rules for the case. So typically what I tell the candidate is that I'm going to describe a business situation that may have occurred at Capital One, and that I'm going to throw a bunch of facts, data, information, maybe some code examples, et cetera, there, that I welcome you as the candidate to take notes, to ask questions, and that the case is designed to be a somewhat collaborative exchange between the candidate and the caser, where I will be asking questions and looking for a good, rich discussion of those, or if it's a problem-solving aspect, a good problem-solving process where the candidate is sort of thinking out loud. What is your approach? What are some of the key things you're thinking about? So that I'm aware of your process and also have the opportunity to interject questions or to provide information where there may be a question or where you may be stuck on a particular concept. A lot of times our cases have a base business situation that is sort of the context for the case, which we'll describe. And then we'll go into a number of both quantitative and qualitative problems. By quantitative, typically what that means is that we're going to show you some code and ask you some questions about it, ask you to write some code. And qualitative, we're usually asking you more open-ended questions. So for the case we're about to step through, we're going to talk about one of the particular systems at Capital One that we call Eno, which is our natural language understanding bot, which interacts with customers. So during the case, you may have your caser give you a handout or show you a representation of a website or an application, in this case, Eno, and they will sort of describe the business context. So here we're saying that Eno is our interactive, multi-channel, natural language understanding financial assistant. It deploys through Android, iOS, or the web. We started out initially with a SMS or text message-based chatbot, which launched in 2017. But then we started developing Eno, which was built around this idea of interacting with the customer in a much more normal, human, empathic, and intelligent mechanism using natural language understanding machine learning algorithms to try and provide a more useful and seamless customer experience. Okay? So one of the most significant interactions with Eno is in the area of fraud alert. And the idea here is that you, as a customer, may have made a charge on your card or not. But Capital One, when we see that charge, we may, for various reasons, think that the charge is something that we'd like to validate or verify with you as a customer, because it could potentially be fraud. And so Eno may interact with you to say, hey, here's an alert. Is this a charge that you actually made? And then we ask the customer to respond to that. And if they say, yep, I made it, great. And if they say, no, I actually didn't, then we sort of begin to take action, right? So the idea behind Eno is that it has much better understanding, that it can understand all the different ways that a customer can respond to a fraud alert, including emoticons and different types of text. So that provides the context for this case problem that we're going to explore. Okay, so now we're starting off with our sort of initial kickoff question, which is saying, hey, when we started developing this with SMS, the chatbot really only can understand and ask the customer to reply using the following two words: confirm, all in uppercase, or deny, all in uppercase. Okay, confirm meaning, yes, I made the charge, it's not fraud. Deny meaning, I don't remember making this charge, it could be fraud. Now, from Capital One's perspective, if we can understand deny response, understand and mitigate fraud, there's a pretty significant benefit to us of $15.25 per deny. Now, the Eno team is proposing to enhance this Eno application to use natural language understanding, machine learning, to radically improve its ability to interact with the customer in a seamless way, which we believe will give Eno the ability to accurately interpret 99.9% of customer responses correctly. So that presents the foundation for the case. Okay, now let's roll forward. So the initial kickoff questions that we may ask are discussion-oriented. So we believe there's a lot of value in this. What do you, as a candidate, believe some of the challenges would be with using the SMS messaging for fraud alerts, as we've described it? And what do you think are some of the considerations in dealing with the customer response? Now, hopefully you're sort of thinking through your head some of the things you might say. What we're looking for is for you to take these questions and then engage with us to have a really rich, detailed discussion around some of these different factors. And so we'll be listening intently to your answers and trying to understand and probe to see, what you come up with. So let's roll forward. So here's some of the things that you may indicate. So you may say, hey, if I send an alert through Eno or SMS that I don't know when the customer is going to get that or when they choose to respond. They may not recognize the number if we're using SMS messaging and might block it. Privacy could be a concern, right? So if we're sending messages and it shows up on your phone's lock screen and you had just, purchased, let's say, a Christmas present or a birthday present, maybe you don't want someone to see that. Of course, messaging may come with charges. It may generate a lot more call center volume if people are calling about the fraud or they have concerns about it. Some of the challenges could be the accuracy of typing on a mobile device, right? Especially across different ages and different levels of experience with mobile devices and different types of devices. With emoticons, there are different emoticons that you might use to respond. A thumbs up, a check mark. Can we interpret those? And then with the what are called Fitzpatrick modifiers, the thumbs up could be 6 or 8 different variants depending on how you personally want to denote thumbs up. Customers might say yes. Oh no, wait, no. They might say yes and 2 minutes later say no. So there's a lot of consideration. And so what we're looking for you to do is to highlight some of these, right? And to really explain from your perspective why that's a consideration that we need to be concerned about, why that's a challenge, what you might do about it, some suggestions you might make, bring in maybe relevant experience you've had. So now once we've closed that out, now most of our software engineering cases are going to involve code, okay? Now in this example, we're going to look at some Java code. But with many of our cases, we do provide a few different options to use a candidate for the code that you'd like to use. So we may have a Java version, a Python version, a Go version, a Node version. But here we're going to sort of focus on a Java version. So here's some code, very rudimentary, simple code, that might be the way that the initial chatbot was written to detect the customer response. So we'll say, hey, take a look at this code, familiarize yourself with it, ask me any questions, but tell me, what is it doing and what issues or challenges do you see? So given the problem of understanding the customer's responses. What problems are there in the way this code was written? What enhancements would you make if you were the engineer in charge to this code, and why would you make them? And given that our match rates are fairly low in understanding responses, 65%, 75%, why do you think that is, and what can we do to improve the match rates? Okay, so let's take a look at what some of those options might be. Well, we're right now only checking for confirm or deny in uppercase. Obviously, we should allow for any case, right? So case sensitivity shouldn't be there. We should also think about what if there were leading or trailing spaces or other characters? Can we remove those? Can we build a list of certain types of emoticons? Common ways of indicating yes or no. What about multiple types of outcomes, right? Null, right? It's up to the client how to interpret this. What about looking for the word confirm or deny anywhere in the customer response? So these are some of the things we'd like you to be able to indicate. All right, so let's roll forward. Okay, now in this particular case, we're going to show you a second example of code. We're going to say, okay, here's version 2. All right, we've taken some of those things and incorporated them into the code. So explain to me what we've solved for in this code. So take a moment to sort of read through this code and having fixed in your head, where you think we've got some things that we fixed and where we're still lacking. Okay, let's roll forward. All right, so we've resolved the case issue. We've resolved the leading and trailing spaces issue, or white space issue. And now we've sort of looked for confirm or deny anywhere in what the customer said. So they might say, I'm not sure. Okay, we would find that case. But what haven't we resolved? Well, we're still not looking for emoticons or emojis. But now we've introduced a new defect. What if the customer puts both words, deny, confirm, in the same response? What if they did deny and then the very next response was a confirm? We haven't solved for that, right? What would we do about that? Okay, so now here's a slightly more complex solution where we've now built up a string array of a few common emojis for confirm and deny. And now we've enhanced the code a little bit further. So you say, okay, take a look at this code. All right, tell me, what we've solved for. Is this better? Is this worse? So I'll give you a few minutes to sort of read through that. All right, so now we're sort of dealing with confirm and deny in the same response, but now we're sort of looking at whatever the last thing we recognize in the response is. Well, is that the right way to approach this problem? Right? We've built some emojis, but certainly not all of them. We've hard-coded the set. One of the things I'd love to hear is, well, all of these responses, you're hard-coding them in your code. If you want to add them, that means the developer's got to go in and add them and write test cases, and then we've got to do a code deployment. Wouldn't it be better if we externalized all those things, maybe to a database or to a content server or some other sort of mechanism? But really, the thing we're looking for is, understanding the way humans relay information is really about natural language processing. And so what we're looking for is for you to sort of highlight what benefits natural language processing or AI ML might be. Now, another thing I want to sort of cover on real quickly is that most of our code-based cases, we also will be asking you to write some code. All right, so we might say, okay, given the things that you suggested we enhance, or given the deficiencies, could you write me the code that would fix that? So you should be prepared to do that in the case as well. Okay, let's roll forward. All right, so that's everything that I wanted to cover from the case. I'll hand it back to the moderators for questions.
Great. Thank you so much, Joe, for running through the case prep here. Right now, we're going to open it up to some questions for either the job fit, the case, or just the recruiting team in general.
I have a question. My name is Andre. I am a student at Rutgers University. My question is the difficulty of the sample job fit questions comparable to the questions in the interview?
Yeah, the difficulty is definitely very similar. Or sorry, the complexity. I guess the difficulty depends on what you're familiar with, but those are, yeah, very similar to questions that you'd see in the job fit.
Okay, thank you.
So I'd like to highlight one thing about the case additionally, because it does come up as a question occasionally. Will the candidate be expected to write code and or trace code? And the answer is, in the case, yes. Both tracing code and writing or extending code is fairly common. We also may have a design question where we ask you to put forward a high-level design for how you would solve a problem given the way the problem is currently written or articulated. Also, sometimes I'm asked about, in the case, the degree to which the code needs to be correct syntactically. We do expect, like in the job fit, the syntax to be correct, but we do take into account the fact that you are not doing this with an IDE or with any sort of computer assistance. It's pen and paper or whiteboard exercise, and so those that is taken into account.
Great, thanks, Joe.
I have another question. For the job fit, do we need to write full code or pseudocode?
So for the job fit, we're definitely looking for full code. And this could be in any language of your choice, as long as you think you can reasonably answer the question in whatever language you choose. But yeah, we're definitely looking for full code, not pseudocode, unless it is a design question, in which case we really just want you to walk through how you would, like, I guess, write out your design, like what classes or objects, what you would use to design a solution to the particular question.
Okay, great. Thank you.
So is it true for the job fit that I can use any programming language?
Yep, you can use any programming language. I would just make sure you let your interviewer know whatever language you're going to be using.
Great, thank you. Great. Any other questions that candidates may have regarding either of the two interviews that we went over or the recruiting process?
Yes. Does the coding in the job fit interview have to be written out by hand or on a computer?
So for the job fit interview, it is all written out by hand. And obviously we know, since you're writing down on paper, you're not going to have access to an IDE that you would have when you're normally coding. So I think we're not super concerned if you miss like a semicolon or a colon or some small syntactical error, as long as you have a general understanding of what you're doing and it is real code, not pseudocode. But yeah, it will be on paper.
Yeah, same thing for the case as I articulated. And then if there is a syntactical error or logic error, a lot of times we will ask a prompting question, like, thank you for describing that. Could you just take over a quick look at your code and tell me if you feel that it would compile, or look at line 6 and 7. Is there anything there that maybe isn't correct? So sometimes we'll prompt if we see something in the solution that isn't quite right. And that sort of gives you an opportunity to catch a small mistake you may have made.
Great. Thank you very much.
And just another question about the case. What language would the case use?
That's a good question. Right now we are building out a strong set of cases, and we're trying to offer those in multiple language options that focus around some of the key languages that Capital One is currently adopting and using heavily. So Java, Python, Golang, JavaScript/Node.js. So if you were given a case that has multiple language options, your caser will ask at the beginning what your preference is for the materials that you are given. And so they might say, for this, you can pick Java, Python, Go, Node, and you can say, okay, I want to do this case in Python, and they'll give you Python code. And then you can provide enhancements or your code in Python. If you don't have a preference, then we'll probably pick Java or Python. But you don't have to stick within that one language either. So you might be doing the case in Java, but then for one particular question, you might go, you know, actually I know Python and there's a Python solution here that I think is more efficient, so I'd like to use Python to write this. So just like with the job fit, that would be fine. If the caser you happen to be working with isn't as conversant in the language you have chosen, they will indicate that, and the expectation is that you can walk them through your solution and the key aspects of that solution, both logically and syntactically.
Great, thank you.
I had another question, and this might be more to the recruiter on the call, but is each portion of the interview weighted the same?
Great question. Yes, so each portion of the interview is weighted equally, and we do conduct all 3 of the interviews to really further assess your qualifications for the role so that we can gain a holistic picture of your capability to be able to perform in the TDP program. Great question.
Thank you.
I have a question too. How long is each interview?
Also a good question. So each of the interviews will last 45 minutes, and you will have a 15-minute break in between 2 of the interviews. I will say some of the interviews do take up less time than that 45 minutes, so oftentimes make sure to come prepared with a few questions to ask your interviewer, but the entire interview duration does last 2.5 hours, with each of the interviews lasting 45 minutes apiece.
Okay, great. Thank you.
No problem. And I'll just pause to see if there's any other questions. And if not, thank you all so much for joining. I really appreciate your time today.